Thank you for joining us on what's expected to be a very exciting and perhaps controversial topic of digitalization of construction. What does it mean and how to do it? My name is James Chu with Project Production Institute, and I'll be facilitating this session. Enabled by increased computing power and faster network speed, digital technology is and will continue to change life as we know it today. But how can and will digital technology change how capital projects are delivered? During this session, experts representing both digital sector as well as the engineering construction industry will present how construction can leverage digital technology to improve project outcomes. Before we dive in, we're going to take a couple of quick polls to see what companies are currently doing with respect to digitalization and what results they are expecting to get. Okay? So to do so, please use your camera to scan this barcode or click the link in the Zoom chat box. We'll give you a few 30 seconds or so to go in and start typing your answers. Okay. Okay. Okay, so we can see that there are a lot of people that's actually implementing 3D modeling. So if you're actually doing something else, please let us know. Knowledge management, RFID sensors, animation and gamification, robots. Monte Carlo simulations. So a variety of different technologies, it seems like is actually being implemented. Okay. Discrete event simulations. Okay. We're going to be closing the poll in 30 seconds. So if you have anything that you want to make sure we cover, please actually add in here. Okay, we're moving on to the next question, which was, what results do you actually expect to get? Wow, 50% shorter construction duration, transaction efficiency, cost avoidance, schedule compression, great, more value, efficiency is real time, shorten cycle time, lower cost. So there are quite a few companies that are implementing a variety of different technologies, hoping that these are some of the results that they can actually get to. And one of the things that actually seems to be pretty out there is the 50% shorter construction duration. So maybe our experts today can actually tell us how we can actually achieve that. Okay. So the results of these polls will be actually uploaded and shared later on the PPI website. So if you want to make sure you actually add something here, please actually do so. Okay. All right, we'll move on. So before we dive in, we're going to actually ask Todd Zabel of Project Production Institute to give us some framework on how to think about what's to come. Todd is the founder and president of Strategic Project Solutions, as well as the founder of Project Production Institute. Prior to founding SPS, Todd founded Pacific Contracting. Established in 1993, Pacific Contracting was recognized in the mid-90s for its use of a variety of innovations, including lean construction, virtual design, and construction. In July 1998, these efforts were acknowledged in the UK government report, Rethinking Construction. Over the past 2 decades, Todd has authored numerous papers on the topics of optimizing engineering, fabrication, and construction. These papers have been published in various technical journals, presented at numerous conferences around the world, and cited by several authors. Over to you, Todd.
Thanks, James, and welcome everyone to what is going to be, I believe, well, it's already started off as a very exciting day or evening, depending on where you are in the world. As James said, a little bit of context as to what we might want to be thinking about when it comes to digitalization and construction. From PPI's perspective, we think there's probably 3 big things that are going on. Let's start off with on the first part here is more on the physical side, where we see robotic and additive type manufacturing becoming more prevalent within the production system for capital projects and construction. Obviously, autonomous vehicles are going to play a significant role. We are seeing autonomous now get into site grading and mining type operations. There are people that are looking at using autonomous trucks to move materials and equipment around, and that all seems very exciting. And finally, the thread that all puts it together is digital. And to delve a little bit more into digital, a good friend of mine who spoke at PPI a couple years ago, Sanjay Jha, he was head of Motorola Mobility prior to selling that to Google, said, look, there's not a lot of new stuff really going on here. What we're really experiencing is a confluence of technologies coming together that are going to allow us to do things we couldn't do before. And he said, 30 or 40 years ago, I got my PhD in AI and ML. He said, but what's happening now, again, as I just said, is the confluence. So what is the confluence? All right, we're starting to see incredibly faster networks, especially with the rollout of 5G, creating its own massive capital investment, extremely fast computing power, and the hope for what might be possible with quantum. James and I actually attended a conference last year where the computational power of quantum computing is nothing short of amazing, and is a game changer if we're able to bring that to fruition, or we should say people like IBM. And finally, what we have now are these massive data complexes in the form of data centers and distributed data management that didn't exist before. So the reality of the situation is we're able to move massive amounts of data and process them at incredible speeds, right? And so the question might be, what do we go do with all this? And clearly, this is resulting in new business models and strategies. It's interesting to see how some engineering and construction companies, to keep within our industry, have now decided that they are moving more to providing digital solutions for their customers. And there's a lot going on there with what might happen with business models, the 3D models, 4D visualizations, any type of data it's its own potential revenue source and value source for those that might own it. There's numerous startups, always very intrigued by people starting up new organizations and new enterprises to go do new things, but not all those things are always new. And finally, every company that's worth their salt wants to be a digital enterprise, and that should not be surprising when we think about it. The valuation and share price of companies like Microsoft, Google, Amazon, Apple, and so on and so forth become very enticing to people that might be in more mundane businesses. If you watch CNBC at any time, there's lots of debate on, is Tesla an automotive manufacturer or a tech company? Their valuation is clearly as a tech company. So as these new business models come together, these new technologies come to market, and we're able to do capture and have access to more data, who will own the data and what will they do with it is a very interesting question. It's not necessarily the question that we're going to answer today, but if I'm an owner, or if I'm a contractor, or if I'm a software provider, and having been all three of those through my career, that is an interesting question. Whose data is that? There is some precedents where people have argued that the engineering on drawings are owned by the engineering company or the architectural company. But this is a big question and is going to cause a lot of consternation in the future. I think the big question today really though is, so mass amounts of data are being processed, moved around and stored all over. How can and will construction benefit? What can we do with additive and robotic manufacturing, or what we might want to call more industrialized production? And what can we do with autonomous vehicles? And again, what do we do with all the data? Three big things that we know are happening in construction is this dawning of automated data transfer, IoT sensors, and we're going to hear a bunch about that today. A lot of information moving back and forth. People talk about data capture. I think if you're chasing data capture, you're probably not, you're missing the point. It's really data transfer, or transceiving, if you will, in the form of radio speak. There is data science. Now that we have mass amounts of data, what do we do with it? AI, ML, RPA. And then finally, there's a lot going on with simulation and visualization. And I think that's what James said that the survey or the poll had told us. All right. One of the questions that we think about a lot at PPI is, do we really need to visualize things that might actually be able to become automated at some point? And so that's a question in itself. So how do these things interconnect? Might be another thing to ponder. But I start with a quote from Peter Drucker. There's nothing so useless as doing efficiently that which should not be done at all. And so we find a lot of people with new technology that are out there to go do interesting things, but as Dr. Fisher would say, perhaps not so interesting. All right. And so the question becomes, are we planning to take all this capability that's been bestowed upon us? And I think it's important to realize the engineering and construction industry plays a role in all this. We're going to build the infrastructure, whether it's the 5G network or 6G, whatever's coming down the pike in the future. We're going to build the data centers. We're going to build the cooling systems and so on and so forth that allow all this to happen. But we're going to build it for people that are going to build the capabilities anyways. Our job isn't to go figure out whether we should build a 5G network or not, or create a faster processor. Our job is to figure out how to leverage that stuff. And so part of what we've done today in the panel, as you'll see, is we have people that are from a cross section of industries that are doing interesting things to actually show us where all this is headed, because we need to decide what might we go do with it. Again, back to that construction is how can engineering construction benefit? Okay. But ask this question: automate, optimize, or innovate? Because what do we go do with this? This is really, I believe, important. Should we automate the current process? Clearly, the more you move to innovate, the higher the value. So is your strategy to optimize? Is it to automate, optimize, or innovate? And we believe that, of course, the highest value is through innovation, and that these tools and capabilities technologies are going to allow us to do things that we don't even know that we could do yet. All right. And so if we are going to just stay in the world of automation, where a lot of people are, and I got to say, if you want to do a startup and you want a high valuation and you really want to, as Roberto Arberlo would say, take the attention of people in the investment community, believe it or not, they're not really interested in blue ocean innovation. They get very excited about automation. And so one of the challenges I believe that's going to occur here is when you talk to the people that invest in technology, they would like to know, how many users do you have? How many users can you get? And we really don't care if you're making money or not. That's not important to us. It's just really, how many customers do you have, right? And so they prefer things that could have a very high customer base, a very large customer base, and a limited amount of innovation when they can select automation. And I find that very interesting and very profound, because you would think, and sitting here literally in the middle of Silicon Valley where I live, you would think that these guys would be about innovation. But the investment community has somewhat changed a little bit and is looking to automate current process. And maybe that gives you some insight as to why some of the software deals for construction have gone the way they've gone, and why companies like Procore have a $5 billion valuation, because they're automating something that people seem to value. So what could or should be automated is a question. If we're going to talk about automation, do we need to automate project management functions? So if we look at project management as defined by the Project Management Institute, and we look at things such as scheduling, organization, procurement, are these things that we really want to go automate, or should we look at this from a different perspective? And clearly, and I think this goes back to what Neil Seth was talking about earlier, the idea of mental models being at play, and those mental models drive business models. So there's a lot at risk for people and what it is they might go do. And there's lack of what I would suggest to you as a framework to properly understand how you might go optimize things or even innovate, if you will. I'll give you for instance, we were observing a situation where someone is using machine learning to optimize drill rig movements. And so, as you may or may not know, in energy field development, drilling is a key element, and it's very expensive to move a drill rig. Some drill rigs might have 100 trailers worth of what they call the spread that goes with it, and you want to get that right. And so if you take all this information that's telling you how your reservoir is performing, you want to figure out how best to move your drill rigs around based on a variety of issues, including potential revenue through production, cash flow, cost, utilization, so on and so forth. Okay. And so someone decided, why don't we use some ML to figure out how to optimize the drill rig movements? And they did it, and they did an excellent job in doing it. However, because they didn't understand the fundamental operation science aspects of what they were doing, the drilling was optimized, the work in process exploded, cycle time got extended, and a lot of cash was used, and a lot of cost was increased because of that. And so I think we need to use these tools wisely and be aware of what it is that we're actually trying to accomplish. And so we propose that what we might see out there is a lot of well-intended actions resulting in unintended consequences. Again, we're not saying this is bad, but we're saying you got to understand what it is that you're trying to do. In another instance, we know that $100 million was invested in a machine learning exercise and data science exercise to understand what might be going on. And the person that invested the 100 million, or the company, said, "What'd you find?" And the data science people said, "Well, we didn't find anything. What is it we were looking for?" And so you got to be clear on your objectives as to what it is you might be trying to accomplish. We're going to propose, and this is why we're PPI, is that the production management provides the framework to leverage this new technology. And when you step back and you think about it, it's kind of obvious. Whether you're dealing with IoT sensors that you're going to hear about shortly, and other types of data transfer, including connection with GPS, GIS, and you might be thinking of flight tracker, DHL's or FedEx's tracking information. We're very excited to have Ryder here with us today and what they're doing. If you think about the use of RFID, we know that tools, hand tools even, are getting instrumented. We've had some discussions with Stanley Black & Decker. On-site robotic type equipment. Hilti has an interesting piece of equipment they've just rolled out. All that stuff is about doing work. And the people that are investing in what I would call advanced technologies are really around how do we do work better. I think the work is more work around what we'd call the production work, and we'll see that later when we look at what's happening in automotive and other sectors in the later session. I'm going to propose to you that really what we need to be thinking about is 4 verbs, 5 levers, and 3 curves. All right, I'll explain in a sec, but if you can get your head around 4, 5, 3, this might give you a different perspective on how you might invest and deploy technology. The first thing is we need to somehow get focused on what it is that we do. And what we do as the engineering construction industry is we design, make, transport, and build stuff. All right. And when you start to move away from these verbs, you get off into all sorts of functional activities that people enjoy playing around with, but it's not really where the value is created. As a matter of fact, the people in the lean community would say that these are the value added activities or the core process. So we can include in design a definition, scoping, opportunity shaping, detailed engineering down to the threads on the bolts and everything in between. Make, we're talking about whether it's high volume manufacture or low volume fabrication. We need to make things, we need to move these things around, hopefully as little as possible, though some believe otherwise, surprisingly. And we need to be smart and intelligent about our transportation, how we look at that. And then we need to build these things on site, and under building, we're talking about commissioning and startup as well, and handover. But these are the big 4 verbs, and how we design, make, transport, and build is really going to influence what the return on investment is. PPI has also been very pushing very hard, if you will, for what we believe to be the framework to understand and influence production systems, and that is the cost, time, and cash you use to go build an asset, or for that matter, build anything, is a function of how you design the product. The product could be something like a nut or a washer. It could be a complete data center, hospital, LNG facility, whatever you may. What work processes, the transformational work that you do to create that product, the interrelationship between the product design and the process design, and then finally, what we'd call the operation science aspect of this is how you allocate capacity, and think about the contributors of capacity being labor, equipment, and space. How you manage inventory. Think about inventory as inbound and outbound stocks. Inbound stocks is stuff in the form of raw materials, outbound stocks in the form of finished goods, and then think of WIP, or work in process, not progress, process, which is anything that's not shipped out to the customer that, that perhaps from their perspective, they're actually using. And then finally, there's variability, which is anything that isn't the way it should or you want it to be. And the interrelationship between these 5 levers. There's no free move on the board. You can't just go change the product design and not have implication for the other 4 levers. You can't induce variability and not have a loss of capacity, growth of inventory, or some combination of both, right? We've talked a little bit about how do we predict things, and this is well known in manufacturing that prediction is usually around the amount of inventory, specifically WIP, that you might have as to how long things might take. And so there's a relationship between inventory and time. And as Dr. Spearman Sr. would say, inventory is the proxy for time. Finally, there's 3 curves. We're not going to get too far into this, but there's a complete lack of alignment and understanding of some fundamental things. And if there's anything we really could get across today, and I understand this is the digital part, but is that there are 4 verbs that we're working on. There's 5 levers to influence it, and then these curves. And the curves say, if you drive up utilization of some kind of a process or system, cycle time or schedule duration in the form of a project will take longer, it'll get extended. And that should be well understood. If you're traveling from point A to point B in your car and there's traffic, then it's going, and so in traffic would mean high utilization, it would take longer than if there wasn't, all right? And the more variability that you put into that utilization, the worse it's gonna get, okay? The amount of throughput or work we get through a process, a system, that could be knowledge work in engineering or in opportunity shaping, or it could be physical work in a fabrication shop or on site, is a function of how much WIP you have in the system. And at some point, it doesn't really matter how much more WIP you put into the system, you're not going to go any faster. Okay. What you might do is tie up a bunch of cash, and perhaps, as the far right curve tells you, you might make things last a lot or take a lot longer than they should. Okay. So really what we want to frame the data around, and James talked a little bit about this, is what we believe at PPI to be something called intelligent production. And we believe that we're at the dawning of production systems where there's supply chains that feed construction, or whether they're fabrication shops, or we could even start getting into healthcare, emergency rooms, automotive manufacturing plants, whatever the case may be. We believe that production systems in the not too distant future will self-organize, and they'll optimize using operation science supported by digital technology, right? And as this session goes on, what we want you to think about, if you will, is as everything becomes connected, right? If we look at this, here's the world we live in with process flow diagrams flowing from left to right. In this particular instance, we're saying that there perhaps is some raw materials of pipe that somehow is going to come out the other end into something on site. All sorts of mechanized and digital equipment does certain operations to it, whether it's trucks moving things around, robots doing work, welders perhaps doing work, forklifts moving things around within a warehouse. All of this is going to become connected very soon. Again, the engineering and construction industry is not driving this. I don't know if Miller and Lincoln have taken and announced digital welders, but I'm sure it's just a matter of time before there's sensors built into those that are going to do all sorts of stuff. Guys that are out there trying to track and trace things, I think through manual means are going to be long gone in the next couple of years. All right. And with that, I will hand it back to James Chu.
Okay, thank you, Todd. Okay, so that was actually a very thought-provoking. So we'll take a look at something that's actually very interesting. So the amount of data bits generated right now, it's no surprise that there is such a interest on the actual science of data management. So we'll take my screen. Okay, so this is the results of the poll a few minutes ago. So not only are we actually talking about a lot of the sensors that are starting to actually generate this information, but also these technologies that people are actually implementing. Okay? So what we want to do is to actually now start thinking about, are we asking the right question? And in order to do so, we're going to be moving on to our next discussion, which is the concept of data science versus operations science. Okay. Let me just go to the next slide. Okay. Okay. So in order to talk about this, we have invited Dr. William Spearman of Liverpool Football Club and Mark Spearman of Project Production Institute. But before we formally introduce them, let's take a moment to set some context for the question. So what are we seeing out there in terms of investment into the world of artificial intelligence, data science, and machine learning? So this is just a few months ago. Worldwide spending on artificial intelligence is expected to double in 4 years, reaching $110 billion in 2024. Again, nearly 500 AI startups across 42 countries raised over $8.4 billion just in the first quarter. Global machine learning market is projected to grow from 7.3 billion in 2020 to 30.6 in 2024. And specifically in construction market, artificial intelligence will reach 4.51 billion by 2026. So there is no shortage of funding that's being poured into the world of AI and machine learning. Okay. Now, with this tremendous investment, the question really becomes, as Todd posed previously, is what problem are we actually solving? Could we be actually solving a problem that we already know? For example, one of the results that actually was fortunate enough to listen to was the relationship between WIP and cycle time. So after observing many, many data points, they said there is a relationship between WIP and cycle time. And my question was, that's a theory that's been proven mathematically many decades ago. What value did this research actually add? And the question I got is, the answer that I got was, well, it proved that data science works. So again, with this much investment going on and companies actually having a lot of people invested in it, we want to make sure we're solving the right problem. So to do that, to actually have this discussion, let's invite the two experts to give us their views. So first person is Dr. William Spearman. He joined the Liverpool Football Club in 2018 as lead data scientist. From 2015 to 2018, he was data scientist at Horo. William has used spatial temporal tracking data to identify tactical insights and key moments in football. He has used physics-based modeling to construct visualizable models of open space, pass difficulty, and off-ball scoring opportunities. Before Horo, William completed his PhD, a measurement of the mass and width of the newly discovered Higgs boson at Harvard University through a collaboration with the European Organization for Nuclear Research. And Mark Spearman, Dr. Spearman is the director of PPI's technical committee and technical director at SPS. Prior to his role at SPS, Spearman was the founder and CEO of Factory Physics. During the past 30 years, he has improved operations and increased profits at over 100 companies through the application of operation science. He is a co-author of the book that you guys very well know, Factory Physics and Factory Physics for Managers, along with numerous other papers. Mark holds PhD in industrial engineering from Texas A&M University, and he's a senior member of IIE. But most of all, he's the proud father of Dr. William Spearman, as you might have guessed. Over to you, Will.
Hi. So yeah, thank you for inviting me to speak today. I'm going to be talking briefly here about what is data science and how it's used in a completely different industry, in this case in soccer. So on to the next slide. This is a quote from IBM about how to define data science, and I quite liked it because it's succinct. It basically states that data science is a multidisciplinary approach to extracting actionable insights from the large and ever-increasing volumes of data collected and created by today's organization. Now, that's nice and succinct, but what does it actually mean? Because in practice, if you ask 100 different data scientists about what data science is, you're going to get 100 different answers. And they're going to usually include buzzwords like AI, machine learning, deep learning, neural networks, recurrent neural networks, convolutional neural networks, et cetera, et cetera. But what does it all mean? And why is it important and how should it be used? So on to the next slide, I like to talk about data science used in an artful way. So kind of a thoughtful way rather than just taking the tools of data science and applying them without a lot of thought. So the key elements for me with this are understanding the process, trying to drill down to what is going on at the most fundamental level, that's creating the data that you're actually trying to analyze. So if you don't understand the process that's creating that data, or that data is describing, you're going to really struggle to model the data. With that, you can have a directed use of machine learning models. So a deep sense of what the machine learning model is good at and how it can capture that underlying process is going to be important. And given that data science is useless on its own, it's basically a tool for interrogating data and communicating with stakeholders, a focus on intelligibility, especially in a field like soccer, where many of the key stakeholders, like the coaches, the athletes, the analysts, are not mathematically technical. That communication and intelligibility is extremely important. So I like to give this little anecdote because it kind of shows a bad way to approach data scientists, and one that I actually did when I first started working with soccer data. So for those of you who watch soccer, you'll know that after a goal, everybody goes and celebrates. So I had access to spatiotemporal player tracking data, and I wanted to build a model that could identify situations that should lead to a goal. And so I used a black box model. I think it was K-nearest neighbors or something similar. And it immediately picked up that one of the most dangerous situations in a game is when all of your team is clustered into a corner of the pitch. And if you've watched any soccer, you'll know that that's ridiculous. You would never put all of your players into a corner of the pitch. But moving on to the next slide, one thing you'll notice is that that happens after a goal is scored. All the players go to celebrate. So the game is stopped and they're celebrating in the corner. So the model, due to desynchronization in the data, had thought that this was a predictive feature rather than a resulting feature of goal scoring. And this black box model obviously couldn't tell the difference. And so this is what it picked up. So let's look at kind of the opposite of that, which is taking a step back and factorizing the fundamental problems in the process. So soccer is a spatial game of controlling the pitch. And time on the ball equates to control of the ball. So to model that, what you can do is you can actually use an exponential process for controlled touches of the ball, which is a very simple process. incredibly simple math, and then use physics to compute the time it takes each player on the pitch to reach a point on the pitch. And putting that together, you get this visualization on the next slide here, which is what I like to call pitch control. And so this is something that illustrates the locations of the pitch that are controlled by each player or each team. And as you can see, as the defenders here in red converge around a blue player, that reduces the control that that blue attacking player has. And so this is nice because it gives us a mathematical quantifiable way to look at control in a soccer game. And what's particularly nice about this is, even though there's some complex math going into this, this is something that you can show to a coach, to a manager, to even a player, and immediately they can see what this is telling them. Now, the layering part, onto the next slide, comes in where you can take different machine learning models. So for example, what we're seeing here is actually what I call off-ball scoring opportunity. And it's highlighting the dangerous locations on the pitch. So in this case, player, I believe it is 31 there on the left-hand side of the right outside the penalty area. He's got the ball, and he could pass to player 16, who's right near the penalty spot, who is completely open and unmarked, and he would have a pretty easy time to score. So the way we get this sort of off-ball scoring opportunity quantification, which is just a highlighting of this dangerous area, is by combining this pitch control model, which is very bespoke, built around understanding the process, with a transition model, which is a more black box approach, with a value model, which is, again, a fairly bespoke model. And so by layering these different machine learning models, some of which are built at a process level, some of which are more black box, you're able to get a fairly visualizable and intuitive understanding of regions of the pitch that are dangerous at a given point in time. And so with that, I'll hand it over to my father so he can speak about operations science.
Okay, thank you, Will. So there they are. William's too modest to mention that they won the championship last year. And so very proud of that. So the question is, what is operation science and what does it have to do with data science? Basically, operation science is the science that describes operations. And as you see on the next slide. And if the oil company that Todd had mentioned that optimized the drilling operations, if they had understood operation science a little bit, they wouldn't have done that, because one of the, as Todd pointed out, one of the basic principles of operation science is higher utilization always leads to higher cycle time. But before we get into that, let's talk about what is an operation. An operation is defined as the transformation of entities through the utilization of resources that create or distribute goods and services that satisfy a given demand. The two key terms here are transformation and demand. Without demand, there's no need for the transformation, so you don't have an operation. And without transformation, the demand wouldn't need you if you're the operation, because they would just get it on their own. So whenever we transform anything to satisfy some kind of demand, it becomes an operation. And there's very many of them, as you see on the next slide. Manufacturing transforms raw materials into finished goods. Transformation transforms the location of a part or a package or a person to another place. Medical service transform ill conditions or medical problems into better health. And project execution transforms many different entities into a single object, such as a building or a bridge or an oil platform in the Gulf of Mexico or something like that. So all of these involve demand. Somebody wants a platform in the Gulf of Mexico, and then transformation of resources. So what operations science describes on the next slide is demand processes. You know, how are they characterized? Are they random? Are they constant? Do we know what the demand is going to be? Do we have a good forecast? How does that work? Resource utilization. So there's your two, demand and transformation right there. The resource utilization describes how the transformation occurs. And the utilization tells you how much of the available resources is required. The variability due to randomness and lack of information, variability always decreases the effectiveness, the efficiency of an operation, as you'll see. And that's seen in the buffering and synchronization. Synchronization is talking about how do you synchronize the demand with the transformation. If the transformation occurs before the demand, then you have inventory, you've created stock. If the transformation occurs after the demand, then the demand had to wait for the transformation. And so we call that a time buffer. And so there's two buffers, an inventory buffer, a time buffer. And we learned that if you have more production capacity than you have demand, then you have a capacity buffer. And the greater the capacity buffer, the less time and inventory buffer you need. That's a key result out of operations science. It's not well understood. And when you pull these things all together, you can describe how much work in process is in the production system, the operation. What's the cycle time through the operation? The throughput in the operation is how much is being produced at any point in time. And those things are all related by various operations science relations. And then when you get to stocks, you talk about how much inventory is in the stock. Do we have back orders? In other words, we didn't meet to satisfy the demand, so they had to wait. Or did we lose demand? If a lot of times, if something's not in inventory, then the demand is actually lost. And so what we try to do is, in operations science, we are taking these models and comparing them against actual situations, because as Richard Feynman said, we're trying to make as many mistakes as fast as we can, because that's the only way we learn. And for instance, we had a model, there's a model out of queuing theory, which says the more work in process there is in a system, the greater the throughput. We tested this model with Chevron, an operation at Chevron, and found out that yes, indeed, the more WIP is in the system, throughput goes up to a point, and then throughput begins to go down. That's not predicted by the queuing model. So we had to modify our model and make it better. And so when we did that, we got a better understanding of operations science, and that led to better operations. So operations science is composed of operations research. We use operations research to optimize queuing theory, inventory theory, stochastic models, and of course, big data, because there's lots and lots of data out there. And there's the two of the three curves that Todd was talking about. Now, like artful data science, we want artful operations science. So we don't want to just use black box models of operations research. We want to understand the process, be smart about what to model and what not to, get some good analytics. And then sometimes we actually use basic physics. So data science and operations science both seek to explain how this complex world works. Data science and operations science both require intuition and basic understanding of the next slide, basic understanding of the system, and we don't want to use black box techniques. So the question is it data science versus operations science, or is it data science and operations science? And so how can the production system performance be improved through better combining data science and operations science? So the next slide shows many of the operations science relationships and some of the data science techniques, and these can be used together. We build basically a model of the production system. Using operations science, we come up with some control policies, use data science to explore those control policies to get better execution policies, and even execution in real time. And so if we pull it all together, we can use operations science to analyze, optimize, and better understand the system, and then use data science to analyze the complex data. And in real time, we can execute and manage a production system more effectively. Now we have some time for questions.
Mark, and we'll actually have the questions at the end of the
Okay.
panel. Okay?
That's good.
All right, so thank you, Mark, and thank you, Will, for a very enlightening discussion. So to actually go back to what Mark was just actually talking about, that these are actually not mutually exclusive, but they are can be actually used to enforce each other, right? And with all the data that's actually going to be generated with the digital technology, you can actually start to see that how they may actually be enforcing each other. So one of the things that a lot of the companies are talking about is we're going to actually use that to optimize. So what is the means of optimizing? I think we actually are seeing the glimpse of what that might actually look like. Okay. So with the understanding of data science, operations science, and what we're actually starting to see in terms of intelligent production, what we want to do is actually start thinking about how they actually come together and what it actually means. So Todd actually introduced this concept of self-organizing and self-optimizing. And it actually has all these devices, equipments that are actually trying to communicate with each other, not just actually provide the information one way and provide information the other way. Okay. The concept that these are the actual cyber systems that actually that are supported by AI, ML, sensors, 5G, and all that, that's actually nothing actually that's new. There are people that are already actually talking about the concept of Industry 4.0, supply chain 4.0, smart supply chain, and digital twin. I think what actually makes it very different is where it says it actually adds the operations science and actually provides an overall platform on which to actually optimize a production system. Okay, so if we were to actually add the digital component to the diagram that Mark just actually presented, we may be able to add something like this. Okay. Sensors, robots, drones, autonomous vehicles, wearables, mobile devices, and applications. Now, with this, the question becomes, how do you actually make this a reality? In order to make this a reality, how are we going to actually gather and process all the data being created across the supply network to where and how to provide feedback and feed-forward control? So I'm not sure if actually everyone's familiar with these two terminologies. The feed-forward and feedback actually means that you actually are trying to, for the perturbation that's actually occurring, how do you actually minimize or anticipate the implications or impact so that we can actually minimize the effect that it will actually have on the overall system? So how do you actually figure where to provide it and how to provide it? Okay. And when we actually start to talk about the actual adding sensors, the question becomes, what to instrument? So what does that mean? Are we going to actually add sensors to pipes, to trailers, to containers? When they're put together, are we going to actually add to an assembly? And if it's actually attached, how are we going to actually attach it? So if you try to actually attach these things, the question actually becomes, how do you attach it? And can it stay attached? And if not, you can't actually stay attached, then you have to figure out how to effectively take it off before it actually some component actually goes into operation, right? What equipment and technology is best suited to capture data at the required frequency? So we know that there are sensors that can actually capture thousands of data points at any point at every second. The problem is, do we actually need that? And what's suited to actually capture that? So we actually seen companies actually using drones to capture information. But for the frequency and the length of time it required, it actually became infeasible because of the time that the drones can actually stay in the sky. So if that's not the case, then what do we actually have to do? Especially on something that's actually very, very high altitude. Okay. So there are many, many questions that we need to still answer. And in order to actually trying to answer these questions, what we have done is actually invited some 4 experts to give us their insight. Okay. So here are the list of 4 speakers. Ravi from Cloudleaf will give us some insights on how to effectively gather and process the incredible amount of information to generate actionable insights. Martin from Stanford University will give us some examples of the digital technologies that are currently being used in the construction industry and the implication that it actually has. Gary will present how logistics of the future will make the intelligent production possible. And Shaker will provide exciting vision into supply chain 4.0. So with that, let me actually properly introduce Ravi. Ravi?
Hi, James.
Ravi is the co-founder and vice president of software engineering for Cloudleaf. He has over 22 years of experience in building software through layered technology architecture, expertise in developing enterprise application and infrastructure on a wide variety of platforms embedded to enterprise systems, skilled at building highly efficient and small footprint enterprise applications that scale. Okay, over to you, Ravi.
Thank you, James. So, start to share the screen. Thanks, James, again. So today we will talk about a next generation of digital supply chains. What it means, what a supply chain that is kind of in the digital age really means. That includes a Internet of Things, and then actual the flow of the material that's happening in the digital chain. So what is involved in that? And we'll cover that today. The real challenges today, any from the perspective of the flow of the material and then the finished goods in a digital supply chain is always being a lot of questions that get asked. Typically, the main question is always, is it going to reach the a given destination in time kind of thing? What kind of condition has it been transported in? How long is it going to take? Is it how many of them am I going to get all the the number of goods that I kind of. So there's a whole bunch of questions and the challenges that exist today. And then the current set of systems are typically back office planning kind of systems where the visibility is really being fairly limited. So we'll talk about that a little bit as we go forward, right? A supply chain typically, is if you start on the demand side, the distribution of the finished goods are happening. There's various stakeholders are involved in terms of, the transportation, the goods, the retail, distribution centers, warehouses, consumers, and so on and so forth, right? And then where these are being, outbound, logistics wise, that's being managed, and then where they're being made in warehouses in various suppliers they're assembled, they're, the raw material has been flowing into it and OEM factories and so on and so forth, right? That's the make part of it. And the sourcing, basically, to make these goods, there's a sourcing again, there's an inbound logistics happening again, through different suppliers, tier 1, tier 2 suppliers in the warehouses. And again, just like the way outbound logistics is, the inbound logistics is also raw material is flowing into the warehouse where the manufacturing sites where the things are. So this is a supply chain network, really, right? If you look at modern supply chains, really, there's a lot of parties and stakeholders involved. There are different channels, different transportation management systems, warehouses, suppliers, and so on. So it's a fairly complex network, basically, right? To provide a really good visibility, the end result is basically, am I going to get my goods in time kind of thing, let's say, right? To get that kind of visibility, it's extremely hard. Today, there is a limited visibility in terms of the location, condition of these goods, and the product flows, right? In a supply chain, the only visibility you get is where, the backend systems kind of integrate, send the data, talk to each other. But the network itself is complex. How do you get a lot more ground level truth so that you can rely on that? What are the information you get? And first thing is there's a limited visibility. The second thing is whether that's true or not is a questionable thing, right? And in not getting that visibility, really a lot of implications. There's a lot of value lost. There's a revenue loss, and then there's all of these network participants are basically working in silos. They're getting a partial picture, not a whole picture. So it really makes it very difficult to today. The visibility is roughly maybe around 20% or so. Based on the systems, and that too, they're out of date. They're stale. It can't be relied upon. Right? So what if we have a way to improve that visibility and provide that in a timely fashion, improve that to beyond 75% with minimal amount of interference to the system, basically, right? With a fairly least intrusive way, if you are able to provide that, what happens, right? There'll be a huge gains. So think about the way things are today, right? The way things are today across this, vast supply chain network, there's very discrete visibility that happens today. It's like, you have a supplier, it leaves the supplier place, somebody enters in saying that, yep, it left the place. It's received an inbound warehouse kind of thing. So you get a touch point. It's a very discrete kind of visibility you get, and that too, not in a timely fashion. Right? It's like when the event happens, you're not getting the visibility right after that, probably a little bit, a week after, maybe a day after kind of thing, right? So it's a very discrete visibility that exists today. You convert that into continuous visibility through a sensory kind of a signals, a various kind of a sensory and a contextual signals. It kind of makes that the whole picture change to a discrete to continuous visibility. We already know as a consumers of the Amazonification of, a goods something gets ordered and you get visibility and continuous visibility. And then knowing that it's going to reach in time is going to be a game changer, basically. This continuous visibility, again, happens through various means, through condition, through location, through contextual kind of information, basically, right? So that is the kind of a game changer in this process. How does that really happen? I mean, it's all good. But so much of investments typically gets made today to get at least even the 20% of the visibility, and there's a multi-party involved. There's a lot of errors in handing out that truth information or the transactional information. So how do you really make sure that the ground truth is really in time and correct? So it happens through the mechanism. If you look at three pillars of a digital supply chain, really is one is on the left side of the systems, you have all these existing systems, right? You kind of work with ERP, WMS, TMS kind of systems, and the business planning kind of systems, sales and operations, and ultimately on the right side, you're trying to give access to a lot of the incident response kind of systems and collaboration, a lot of interactive collaboration. And at the bottom, the real layer is the data acquisition kind of, we'll talk a little bit more into this, right? Sensor data, business, and the carrier integrations and 3PL data, contextual integrations. All of this kind of feeds into a framework of a digital supply chain, OS basically, right? Where first is, as I talked about, the network itself is fairly complex. There's thousands and thousands of parties involved in materializing this network. So that's one. Second thing is the data processing. You ingest and you process it. And third thing is making sense out of that data. So we'll cover each of these in detail. So if you look at the supply chain network itself, when you set it up, again, when you say network, it doesn't necessarily be just the suppliers and the warehouses and manufacturing sites and then the logistics kind of things, right? There's a lot more to it. What happens in a given item level? Is there an excursions on that? So when you talk about a network could be fairly extensive, and how much of this network is visible to who, you partially control that through, whatever the security access controls. Leaving that aside, first of all, you need to do the modeling. So the modeling itself is done through the, really hyperscale, graph DB kind of, it lends itself very much a connected set of entities into the system. So that's what the supply chain digital twin modeling would be, right? With a very high scale kind of modeling. Now, once you have modeled what your supply chain network looks like, now what starts to happen is a data acquisition that starts to happen, right? Data, you acquire the data, you normalize it. These data is basically coming in streams, high volume kind of, of events as a streams coming in. We just kind of, as a humans, we can't even fathom this, right? So there's got to be a processing that data is happening and translate into higher level business events, and from the business events into a real time kind of, alerts or excursions or whatnot kind of thing, right? To do that, again, like James talked about this a little bit, it's not about one sensor, from one place to, a kind of thing, do you attach a sensor to your container? Do you attach a sensor to your truck? What are all the different kind of signals coming in? Happening through different enterprises. These devices are manufactured and created different enterprise for different use cases. So what has to happen is you have to create a system where you can ingest signals and the data from any device, any kind of contextual signals. So you need to have an integration layer, just like an enterprise integration layer. You need to have a signal integration layers to support these kind of a variety of device signals, right? Then once you have that, what do you do with it? So you kind of have to create a model. So obviously this is a large amount of data coming in. You have to make sense out of it, and it's humanly impossible. So you have to create models, right? On the top of these real-time data coming in to say, what is a predictive ETS, for these things? Is there a possibility of a condition excursions? What is a utilization? All these things. There's a different models has to be developed and deployed so that you can get a view into what the predictability and the insights are a little bit, right? So. And again, you have to go through transformations of the data, basically the raw data into business events, into higher level models, and so on and so forth. These are all the machine learning models to a business rule centric models. Business rule centric models are where you're trying to apply a lot more the domain knowledge you gather that you put in there. Obviously, if you start with an enterprise, they already have some knowledge. You take that, you translate it into business rules, one kind of that, and you use that to transform the data. The second kind is basically you build on a large amount of data, you try to extract, synthesize, the essence, what are the business rule equivalent of essence automatically through ML and AI models, machine learning models. And you use both of those in an industry like this to leverage and to derive high value basically, right? So all the techniques in your tool chest has to be used to really get a predictive insights and to get a much more valuable information. Across all these things, IoT, Internet of Things, one of the key things is you get various location, condition, various kind of signals. When we say condition, like, it's temperature, humidity, and shock, and so on and so forth. One of the key element is the time. Freshness of the data is always key. the data ages, you hardly get much value out of that. So time is one of the important component along with the condition and location in this data, right? So now this goes back to James and Mark kind of talked about a little bit of how do you integrate this? Data science is typically giving you a view into a given stage. How you imagine raw material is flowing into warehouses, and the set up steps you're going through to transform that into a finished goods, through a WIP process, and then finally you are transporting those finished goods into a outbound logistics through various touch points, let's say, right? You have a view, you have a model you start with, and that model visibility is provided through this visibility platform, right? But one of the things it still doesn't answer is basically, let's say I have a million kind of finished goods at 2 or 3 warehouses in different countries. Am I able to get those in time? If so, what are all the things I need to do in the middle? Like, for example, if I'm transporting from a LAX to, like, let's say, some other, airport in a different country, how many kind of, planes, or how many kind of, cargo planes I have to use, and then if you go from there to a warehouse, let's say you're traveling like on an ocean cargo, what happens is, how do you parallelize these things? How do you set that up? As a model needs to be developed, which is operational science model, really, right? In terms of to get this many widgets or the items at the end, what are the things you need to do? What is the flow, and what are the parameters? What is the model to be developed? So one of the things what we have done is Cloudleaf kind of has a sets of APIs. We fed that into SPS has this very cool optimization engine, basically operational science optimization engine. We fed in really. We took all these signals, transportation signals for the outbound logistics, and we took a route plans, a multi-segment route plans, fed into it, create the model. Once we create model, optimized it. The minute we do that, it already bubbled up a set of bottlenecks saying that, hey, you're trying to transport a set of goods, a bunch of pallets, bunch of, the finished goods, and then the raw material into, from location A to location B, you should be, rather than 10 trucks, you should be using 100 trucks kind of thing, right? The minute you start to play. So there's an auto tuning mechanisms. It started to identify the bottlenecks and then start to recommend the tunable parameters that automatically we could use, right? We can leverage. And then we took that and we fed that back into the WIP planning again, right? We took that and we fed that in. We changed the whole model about what the segments look like, what the parallelization that needs to happen. And then, that again changes the outcomes basically, right? So this is a continuous auto tuning cycle that you go from where the model to the actual, WIP kind of model into the optimization model, operation science based optimization model to auto tuning back to again. This becomes a completely a cycle. Given the amount of the data we just talked about, this is only the way to do it. The only way we could do it is the optimization and then the whole cycle to complete the required kind of to fulfill the requirements basically put on by the customers. I kind of pause there for a minute. I think pretty much done, but that's the end of the presentation. Thank you.
Okay, Ravi.
Yeah.
Thank you very much for a very, very interesting presentation. And as we actually has, Ravi just actually has described, we have started to actually integrate the sensor data along with their data science technology with operation science engine to provide real-time feedback so that right adjustment can be actually made in terms of logistical capacity. So again, this actually is a very at the beginning, but I think it actually has produced some insight as to what's actually possible. So with that, we're now actually going to go into we're going to actually invite Martin Fisher. Martin Fisher. Yeah. There you go. To actually talk about digitalization of construction. Martin Fisher is a professor of civil and environmental engineering. By courtesy, computer science at Stanford University. He is also the director of Center for Integrated Facilities Engineering, which is called SciFi, a senior fellow of the Precourt Institute for Energy and coordinator of the Building Energy Efficiency Research at the Precourt Energy Efficiency Center. His research focuses on modeling, predicting, measuring, and improving life cycle performance of built environment. He's known globally for his work and leadership in developing virtual 4D modeling methods to improve project planning, enhance facilities performance, increase productivity at project teams, and further sustainability of the built environment. Martin, over to you.
Thank you, James. Very, very happy to be here, and thank you for your leadership and the leadership of all your colleagues at PPI and SPS. So this session is on digitalization of construction. What does it mean and how to do it? It's a topic that I've enjoyed my entire career because, as many of you know, I find that when we have better tools, we can do dramatically better things. Yes, these are just tools, digital methods, but as you know from all aspects of your personal lives, with better tools come very, very new opportunities, and that's what I hope to show today. I see, broadly speaking, really two main opportunities from digitalization. One is to sort of get rid of inefficiencies, and I briefly make a few comments there in the process we have today, or in a slightly reorganized process, and then, as Todd alluded to, from automation optimization. That is extremely exciting, but also a bit more challenging and interesting. So, give you an idea of what I do at Stanford, mostly because of our fantastic graduate students and colleagues. So these are the classes I'm involved in this academic year, from managing sustainable building projects to managing fabrication construction, collaborating with Ed Pound from PPI. That was super interesting. Virtual design and construction, construction robotics, industrialized construction, AI and frontier technologies. Just as a little bit of background, in addition to James' introduction of what I work on at Stanford. But I want to start with something very, very simple. At the end of the day, we all want results. Like William showed, we need to score a goal. Or it's a little trickier actually in our field, right? What is the result we actually want? What is the value we're really adding? That is something, in my experience, that needs to be defined quite a bit more carefully to really make use of optimization, of data science, and so on. But if we want results consistently, we must have a process, and that was already showed very nicely. And you cannot have a consistent, good process if you don't have data. So in other words, no data, no process, no results. I realize this is painfully obvious, or maybe annoyingly obvious, but if it was really so obvious, then we would have much better data today than we have. Because one thing that has surprised me over the last decade or so is still how little attention we in construction actually pay to the data. I realize that's improving, but that's a reflection. Given this really obvious statement here, I think we should have better data. So I was going to make a few comments on the sort of low-hanging fruit, immediate opportunity. This is one of my first projects. Was I was working on this bridge in the background, redesigning it so it could be more constructible, and that really got me into building information modeling, 3D modeling, etc. because I spent most of my day looking for the right information. Who had the latest information? Did somebody have a newer drawing? Who else is working on this, etc. Basically, the visibility transparency wasn't there. And I saw myself and everybody on this team and in other teams wasting a lot of time. And basically, I was lazy. I didn't want to have to do that. I wanted to have the information working for me, but instead I was working for the information. And so this I find always a very, very good question that was posed to me some time ago by Kathleen Liston, one of my PhD students from some time ago. Yeah, she's asked me one time, hey, are you working for the information or is the information working for you? And I'm really excited that we're getting to a point where information is starting to work for us. But where is this information? Where is this data? And typically we find it's stuck in many, many silos, many, many different ways of being organized and formatted, etc. And this is what we have also observed, the effect of that, what you observed. My colleague at the time, John Haymaker, and former PhD student Forrest Flego, they studied a engineering organization in San Francisco, well-known, large engineering organization. And they found that they spent 54% of their time managing information, not doing design, engineering, the things that they are really paid to do or that really adds a value. More than half of their staff, of their engineers, is there to just manage information. We found even more staggering number when we, in the time of the first .com boom, studied the processes that were being used. And that was work by, at the time, Alex Baron. And he found that 84% of the work in, for example, monthly progress billing would fall away if we just connected these different steps with information. 5 or 6 work hours are basically wasted. And the situation is maybe a little bit better today, but I'm not sure that much better. But this just shows the opportunity that's immediately available for us, money that's lying around basically for us to just pick up and do better projects. So, but a lot of you I know are already picking up this low-hanging fruit. So what is the slightly higher hanging fruit? So back to this, basically we want results, right? And then, so if you think about this a little bit more, right, it's very obvious that you can't do much without information. And you can't do anything well without good information. Again, I realize it's painfully obvious, but we should therefore be able to say how much better is our information today versus last year, how much better does it need to be next year. And so that's where I want to show the opportunities that we see from a number of tools that already were, you mentioned them in the survey, and that already be alluded to by some of the previous speakers. But basically, the combination or confluence, as Todd called it, of emerging technologies creates really unprecedented opportunities for breakthrough performance. And I'm just listing a few categories of tools here. There's many more that you have listed. And any one of them is already a big deal, but the combination is really, truly exciting. And I think that's what we're discussing here. So I love Todd's statement and James that we are looking for self-organizing and self-optimizing production systems. So this obviously requires good information. So how good is the information that we have and how is it getting better? So I want to show a little bit of work from our lab on this, just as an illustration. So we need to establish a demand, right? If we don't have a good demand, as Mark mentioned, then yeah, the rest becomes really guesswork. So there's some technologies here. We find virtual reality and optimization be very, very design optimization, multidisciplinary design optimization to be very useful tools here. There's others, but that should serve as illustration. So one of our current grad students, Cindy Durkin, had the pleasure of working over the summer with MWH and WebCore on a wastewater treatment plant in San Francisco, and they were deploying virtual reality tools to basically organize design reviews and create a better design that was more operable, for example, here. which then creates a better demand. You have a better design, fewer change orders later, less variability, more predictability in execution. The VR tool was really, especially these days, extremely helpful in design reviews, multidisciplinary design reviews, to make sure again that we had the right design. So these visualization methods are extremely helpful to give people an experience ahead of time, before we actually stand there physically and say, oh, don't quite like it. We can also, of course, automate many of the design tasks, although we still have a long ways to go. But we're seeing in practice topology optimization that's being applied by companies like SOM. It's an important, relatively small, but still, of course, very important part of the design of a structure. In collaboration with KPFF, structural engineering company, DPR, and also Herrick Steel, we are able to, I think, move the needle. That's work by Filippo Renali on the structural optimization of steel structures, to go beyond basically the gravity load, to bring in drift criteria, to consider composite structures, moment frames, but also, very importantly, the connection design. So to include architectural constraints and structural strength, stiffness, constructability, and ductility constraints. This has been really eye-opening work for me. Seeing that this is possible to do, that we can basically automate the design of a steel structure for many important criteria. Of course, there's more, but still already more realistic than exists today, but also tells me we still have a ways to go in terms of a self-organizing system, because the structural design is just one important, but just one part of the design of any kind of structure. And we need to connect these different disciplines. So yes, we're making great progress, but we have quite a ways to go. But we are seeing already from these optimizations significant material fabrication changes, extremely fast structural design time, which really changes the business model, right? It allows a very different design process in terms of exploring different options, higher safety, and yeah, basically by being able to look at thousands of feasible scenarios versus just a few. We can do the same with schedules. That's a tool that has come out of my research lab, being commercialized by a company called Alice, Renee Mocha's work. This was collaboration with Clark Pacific, a precast company, where basically over the course of 3 days, we analyzed the 4 construction strategies they really wanted to understand. 56 construction schedules, 500 schedules generated. Basically 10 minutes for generating a new schedule for each new alternative, and basically combining real field data, building information model data, construction knowledge, to create these insights in just a matter of a few days, to understand the cost and duration trade-offs for the different strategies that they wanted to explore. So again, this gives us ability to predict, to bring the knowledge we have in a consistent way into the design of a process, the demand, the schedule, which is an important contribution, I believe, but again, just one of the contributions needed for a self-organizing, optimizing production system. So these are illustrations of how we can establish the demand better, but we can also see very exciting technologies to establish the supply, the transformation, a lot of what Mark talked about. I just want to show some examples from the IoT sensing world and robotics. But this allows us really for the first time to create consistent real feedback loops, which are of course incredibly critical for continuous improvement. So the first one, there's an IoT device, a crane hook developed by Versatile that was deployed on this project by Clark Pacific and others, many others, but the one that we were able to observe in San Jose. And basically it gives us data on every crane operation. So it's no more guessing, no more like these anecdotes, oh, that is always in the way, etc. No, you have the data for every operation, which is really extremely refreshing to see. And so just what you do with this. Couple examples that were presented at Future Tech at ENL a couple months ago. And what we've seen is when you go from sort of your average data of how long does it take to put the double T into place to it takes this long for the double T on Monday morning at 10:52 and so on. When you have all of that data and you use that then to predict the work that's ahead, you can reduce your prediction error by about 50%. So you can establish a better demand for your crew, which allows you to better match your demand and supply, of course. Or you can also, I mean, it's simulated, but based on simulation, we could see that we could actually install 7 more parts with a 90% chance of achieving scheduled targets because we have the better data. You can decide where you want to have that, you know, maybe 90% is not good enough. You want 99%, so then maybe you need to go back a fewer parts, or maybe you want to live a little more dangerously. You can maybe push it a little bit more. But this allows us now to understand really, yeah, the variability in a production system, and then we can design our daily, weekly, monthly forecasts better. Robots actually starting to do similar things. In addition, they also do actually work in some cases. So 2 of our grad students, Cynthia and Hessam, have been able to work with various companies to observe and document the application of robots on site. I'll just share a couple examples. Together with Swinnerton, we were able to see what can you do with Spot. And basically, in a nutshell, instead of sort of tracking one thing that you typically do when you walk around a site, you know, you can put many sensors on Spot and you can get data on all kinds of things that allow you to then connect with more things. So this is back to sort of integrating, having a data set, that single source of truth that connects to many, many applications. So in this case, production tracking, streamlining payments, quality control, automated progression of schedule, and air quality monitoring, for example, cutting the payment cycle quite dramatically by a factor of, yeah, close to 10. Because you can collect, you know, reliable data very, very fast on a number of topics. This is precursor to I think the robot from Hilti that Todd mentioned that had just come out. This was version 1 of it by a company called Enlink. We were able to work with Cruiser Smith, and what we saw that this drilling robot reduced task time by 11%, cut, and I think that's really, really critical, muscle strain hours from 60% to 1.3%, a dramatic reduction, improvement in health and safety, reduced rework a bit, almost by 50%, increased the accuracy, which also then important for prefabrication, and cleaned up the site automatically, increased cost by 13%. So you have to decide, is this worth those 13%? I think that cost will come down, will change. Also, it's different business models are developed for the use of robots. But already, I think, extremely promising results from basically, this was the first application of this robot on a project. Then with Mortensen, we're able to look at the application of a layout robot. And basically, we found that you can, again, achieve higher accuracy. it is, and you consider the setup time a bit slower, but on the other hand, you only need one operator. The actual execution task is quite similar without the setup time. Again, this was the first application, so I think for the first application, really very, very promising. But what we, what we see also with these robots is that you can extend, often allows you to extend the operating hours because you can do certain things, for example, at night that today wouldn't be possible because of staffing or other requirements or regulations. So I guess I should have hit this a little bit sooner for the video to play, just to see a bit. But the other thing that the robot, the layout robot does, it prints more information. So you can transfer your information from the 3D model to the field more completely. So what we see is this information is getting more accurate, reliable, consistent, timely, up-to-date, complete, more granular, relevant, computer interpretable. These are all very, very important to have in the context of automation and doing better things more consistently. Yes, you get more granular data, which is really critical because that data you can actually believe. It's too much for us to look at, but the computer can help us with that. So what we have seen with these examples is project teams can better match demand and supply. But we're not yet at a self-organizing, optimizing production system. For that, I find the levels of digitalization, these levels of digitalization is quite helpful to think about. Basically, those levels of, though the data allow you, or the system, just the data and the system, does it give you a description? What is happening? Where were the players when the goal was scored? Explanation, why is it happening? Prediction, what will happen? That's what we saw with, for example, what Alice is trying to do, the structural optimization is trying to do. And then prescription, what should be done? What we have seen really over the last couple of years is that the technologies are dramatically improving our description of what's happening, which we have never had before in our industry. But management, the value is really added, and what management expects, what we have found is what should be done, a prescription. And to summarize, we have, I think, a ways to go towards a self-organizing, optimizing system, because that has to function at a prescription level. We have a ways to go to explain why it's happening, what's happening, to make accurate predictions, to validate our predictions, so that we can go to a prescriptive system that can self-organize. So that's where I see we are, but it's an exciting journey towards a self-organizing and self-optimizing production system. And to get started, we need to pay attention to data, because without it, we have no process and no results. Thank you.
Thank you, Martin. Share my video. Okay. Thank you for that overview of all the technologies that's actually being implemented in our industry, and talking about the levels of digitalization. So there's a few questions that actually prompted, but we'll actually get to that after the presentations in the shared panel. Okay. So next, we actually invite Gary Allen from Ryder to talk about supply chain and logistics innovation. Hey, Gary. Gary is Vice President of Supply Chain Excellence for Ryder System, an industry-leading Fortune 500 commercial transportation, logistics, and supply chain management solutions company. In his position, he's responsible for overseeing product development, solution design, continuous improvement, business analytics, and automation to support business development and existing operations for the overall supply chain and dedicated transportation organization. Gary has more than 30 years of experience in supply chain services. His area of expertise range from process improvement, logistics outsourcing, new product development, business transformation, system selection and implementation, operations, operational due diligence, business performance improvement, overall supply chain strategy. So I'm sure everyone's very eager to hear what Gary actually has to say. So
Okay.
we're going to actually pass it off to you.
Thank you, James. Let me present my screen. I think it's blocked me out until you stop. There you go. Okay. Pull up the presentation. Okay, what I want to cover today is focused on the logistics side, and I think that the past presenters kind of highlighted a lot of the topics. What I want to cover are some of the things that we're seeing in the industry, what Ryder is doing to apply those new solutions, as well as how does that affect the construction and project industries today. From a Ryder perspective, I think most of you are aware of Ryder. I just want to kind of highlight a few things because I think everybody is aware that Ryder manages transportation, but we do a lot more than transportation and trucking. You know, we have almost 40,000 employees across a variety of different business units. We have about 10,000 drivers. We have 55 million square feet of warehousing space that we manage today. We also have technicians that repair, maintain vehicles. So we do a lot more than just trucking and transportation today. And in fact, you know, if you're focused on the construction and project side of the industry, the industrial segment is probably about 30% of our business today. And so that includes customers in the oil and gas space, whether it's Chevron and Shell, the utilities and the telco space, whether it's Verizon, Florida Power and Light, as well as construction. We do a lot of elevator work with Otis. We do warehousing distribution as well as to construction sites as well. So what I want to highlight, a lot of the past presenters covered kind of what's happening in the industry today. And the exciting thing is there are a lot of new innovations going on, as Todd mentioned. You know, I think the challenge is, you know, there's so many new technologies, so many new companies. The past presenters, whether Martin and Ravi, kind of highlighted the explosion of data. It's a huge challenge for the operating companies out there. They'll kind of talk through what we're doing. Ravi covered IoT, you know, the impact of e-commerce, kind of the wanting it now, as well as asset sharing. If you consider we own and maintain over 270,000 trucks today. We have more trucks in North America than anybody else. So how can we share those trucks across customers? And in fact, our oil and gas customers kind of pushed us down that path to look at how we can share. And then looking at it from a holistic network perspective, you know, there's a lot going on, but how do you connect the dots? You know, Todd kind of talked about, you know, intelligent production, and we look at it as intelligent supply chain and intelligent logistics. And then lastly, getting into the new vehicle technologies as well as autonomous. And so we'll kind of talk through. I like to summarize kind of the disruptive trends really around three categories. You know, one around the Amazon effect, which is impacting the focus on the customer. You know, two around Uber, which is more around kind of that asset sharing and sharing economy. And then, you know, three around alternative vehicles or the Tesla effect. You know, so we're going to talk through what we're doing and how to apply it in the construction project industry. You know, what does it mean? You know, there's a focus on customer demand, data analytics is exploding. You know, the other interesting thing is the impact of wage and labor pressures. You know, for us, you know, we employ a lot of warehouse workers as well as drivers and technicians. And there's a dynamic of the wage rates that are increasing, and that compared to the technology costs that are decreasing is actually bringing in a lot of new innovations into play that a lot of companies weren't thinking through before. And then also availability of replacement parts, you know, additive manufacturing, 3D printing has been around, but a lot of those applications are kind of coming in light now. And we've really coined it around three main themes to think about. One is the digital supply chain. So how do we use data to drive insights? How do you look at that across your supply chain, not in the silos that were talked about before? And then how do you make the customer and the user experience kind of front and center? And then around the distribution materials management, you know, how do you use the technologies that are out there to not only optimize and drive productivities and efficiencies, but how do all those nodes across the supply chain become intelligent to either track information and make sure you understand where the goods and materials are. And then the last thing around transportation, if you look at it, all of our trucks, we have 270,000 trucks, we have almost 10,000 drivers. All of our trucks have GPS telematics in them, right? And then we also deployed an app that we can digitize trips and remove paperwork. So how can we leverage the sensors, the telematics, the IoT to use that information to kind of move from not only visibility that Ravi touched on, but how do we use that to improve transparency? And the difference around transparency is more of the context of not only what's happening, why is it occurring, and then how can you avoid it in the future? So some of the things that we're doing at Ryder today, first is around digitizing supply chain. One of the tools that we deployed is a tool we call RyderShare. And Ravi touched around visibility, but we look at RyderShare as end-to-end collaboration and transparency. So any of our logistics operations, if a customer does business with us, we deploy this tool. And this is from tracking shipments to tracking inventory inside a warehouse. And then more importantly, how do you monitor the exceptions and then over time be able to predict those exceptions to minimize disruptions across your supply chain. And we've seen tremendous benefits around automating that activity, especially around getting people off of phones, keyboards, and utilizing RPA to drive efficiencies. Another area is around analytics. On my team, we have about 75 data science and data analytics team members. And we'll describe what they're doing around the soccer example of kind of a heat map of players. Think of this as we are tracking, every asset, every forklift. We're also deploying IoT around where people reside in a warehouse, in a materials location, to be able to look at not only the flow of people and goods, it's then what do you do with that information around comparing plan versus actual to then drive improvements. I think the challenge around all the data and what's happening in the industry is what do you do with it? And then how do you make it easy to interpret at a user level and an operating level is one of the key challenges. On the asset sharing side, I mentioned our oil and gas customers, as well as our food and CPG customers drove us to say, hey, you're dedicating trucks and drivers to our business. I'd rather look at it as a regional approach to be able to share assets across businesses. And we deployed a product that we call Coop. Right now it's in 3 different states and we're looking to roll this out nationwide. But think of Coop as kind of the Uber for trucking, right? If a customer has available assets, or even we at Ryder have available assets that we want to deploy and share to improve utilization, we can go into the Coop app and it's a very simple transaction. I'll talk about the bottom left around smart warehousing and automation in a second, but on the advanced vehicle technology, we are in the midst of deploying new technology, whether it's electrical vehicles, whether it's EVs, as well as autonomous vehicles today. And we'll kind of talk about the world of autonomous. The autonomous vehicles today, we partner with a company called Ike. And a lot of the lanes that we're piloting are more of the long haul highway type activities. Our view of autonomous is it's going to take a few years, but the long haul nodes are kind of the first thing to go, along with private yards. And if we think about construction and oil and gas and remote field operations, that is ripe to leverage the autonomous technology. So if we look at how do you deploy and what technology is ready now that our customers or we're deploying on behalf of our customers, a lot of the autonomous mobile robots, and these are units that bring goods to an operator. Now, a lot of this may not apply to construction, but in the package world, parts world, these are readily available, very economic. They drive flexibility. You can move them around and deploy them across facilities. Drones, Jay made reference to drones. Drones, I would say a portion of it's ready now. if you think of how we're using it to alleviate yard checks. So if we have a large operation with hundreds of vehicles, we don't have to send a person out to actually do inventory checks. Inside the four walls, it's a little further off because of the accuracy getting down to a unit level in a location is still a challenge. Bot-based ASRS, which is automatic storage and retrieval systems. It's far more flexible now because you can interact kind of the bots like a AMR with more of a fixed unit. Vision AR, Martin kind of talked about, augmented reality and visual reality. This is ready now. And a lot of the construction field operations are deploying the technology. The thing that's changing in this space is it's alleviating an additional device to be able to do scanning, right? Part of the challenge was the optics and the graphical displays to be able to pick up barcodes. So now with some of the newer technologies, we can use AR to basically eliminate handheld scanning. But then if you have any type of complex, value-added assembly or remote diagnostics, you can then patch in from a central location. Autonomous vehicles are ready now. They used to be pretty expensive. They've been around. AGVs have been around for decades. What's changing there is the price points coming down and being, it's far more economical than it has been in the past. Analytics and insights. A lot of what we're talking about today is how do we use this data to drive, automation intelligence. And that's really the key. Is right now, a lot of it is trying to normalize data. If we look at what Ryder does, we have thousands of customers, we have hundreds of execution systems, and really the first challenge is how do you normalize that data? How do you figure out what the use case is? And then how do you translate that data so it's easy to use in the field? And that's really a lot of the work that we're doing today. And then the last piece is around IoT. As I mentioned, we are tracking all of our MHE in the field. We are tracking every truck, every vehicle. So it comes down to what do you do with that data? What does it mean? And then how do you avoid exceptions and disruptions out in the field? What's coming in the future is more of what the previous panelists talked. It's more around AI. We are doing things around machine learning, more around forecasting demand, forecasting labor, forecasting transportation needs. We see a big opportunity to be able to leverage that data around how do you simulate across your supply chain, each of the nodes in your supply chain, and then combine that simulation with the data analytics to actually, look at more predictive and prescriptive type of capabilities. The other thing that we're working on and what's coming in the future is how do you pull all this data together in an integrated fashion across numerous parties, numerous systems, to be able to then simplify and do something with that data from a control perspective, right? And so that side of the space is changing pretty dramatically today. So we see a lot of advancements in the future around kind of this fully integrated IoT solution. If we look at and switch gears around the construction industry, I think everybody is aware of kind of the impact around project logistics and what does it mean. So trying to apply some of the technologies and innovations to address things like remote locations, challenges with health and safety. How do you actually look at the reverse side of it, being returns and the materials coming back, as well as the challenge around complexity. I mean, I would say construction, oil and gas, and any of the project logistics, frankly, is one of the most complex supply chains that we see out there. And predominantly because of the number of participants, disparate systems, and then trying to bring all that data together. So if you look at this from a holistic perspective, I really break it up in three components. One that we talked about up front is how can you translate, the planning from not only a production or a site plan or a construction plan, but how do you translate that into a production plan? And then from a logistics perspective, getting that down into what I will call like a logistics release, or being able to quantify that into shipments and transportation needs and warehousing needs. The thing that's changing on that side is network design used to be something you look at monthly, quarterly, annually. It's now shifting into more of that daily, weekly simulation to say, do I have enough nodes? What do I do with the flow of materials? The second piece is in the middle, and this is kind of this inbound supply chain portion of it. And what do I need to do around the visibility of the controls up until staging of materials? Do I look at offsite facilities, staging configuration before I get to a job site? And then the last is kind of on the job itself and some of the complexities in the field. And then just wrapping it up around what does this mean around if you apply the technologies to the construction and project-based business. The first is to increase project certainty. We talked about, improved planning. The second piece is then reducing the single project cost. So looking at how do we leverage visibility and transparency? How do we optimize the material flow? How do we look at the nodes in the supply chain to reduce complexity? And then the third segment is then how do we get into this industrialization segment around trying to standardize, once you normalize the data, to be able to standardize your processes so you can then use that data across all the different segments. And then the third piece is then optimization and being able to leverage all the new technologies to be able to drive efficiencies from a project base. And then just in closing, closing thoughts around things to keep in mind for the audience. The first is, how do you manage the data? What is the use case? And then how do you simplify it to be able to utilize that data to get to more of, this insights and predictive? The second piece is how do you take a holistic approach around intelligent, not only production and project management, is intelligent supply chain and logistics planning as well. The third that we talked about is that transparency end to end across your supply chain. And then the fourth is around how do you integrate this across all the different tools and technologies and take a control and systematic approach behind it, and then leveraging those new technologies going forward. And then just lastly is how do we work together across different suppliers, capabilities, and partners to be able to drive efficiencies towards the future. Thank you, James.
Thank you, Gary. That was very well presented and opened our eyes actually to what possibilities that there are in the world of logistics, including some of the new equipment that I have never seen before. So thank you very much. Okay, so I'm gonna share the screen here. And we're going to now go to talking about intelligent production, specifically about supply chain 4.0. And the presenter is Shaker. Shaker Tatarajan is the Chief Supply Chain and Inventory Officer for American Eagle Outfitters. Shaker has held a leadership role in major corporations such as Walmart, Target, Walt Disney Company, Anheuser-Busch, Pepsi, and Coca-Cola. He led operations for these corporations as was instrumental in creating digital supply chain capabilities. He's credited with creating game-changing capabilities like scalable grocery home shopping models, Magic Band, Cool Lift, DSD innovation, digital supply chains, industry's first control tower. Shaker is responsible for bringing emerging science to companies and has led teams that have generated over 1,800 filed patents. He personally is just informed the updated number today. He also personally has filed 400 patents and has 120 of those have been issued. Very impressive. So over to you, Shaker.
Good morning, everyone, and for people in different parts of the world, like wherever you are, really excited to talk to you all. I want to actually give you guys a little bit of my personal background and kind of walk through where I think like supply chain is generally headed. And before I kind of start talking about the topic itself, I just wanted to give you a little bit of context of like my background and how the convergence of all the things have kind of come and why the supply chain 4.0. Um, again, like, as James mentioned, I had the good fortune and probably by God's grace, um, was part of a lot of big companies, and they were all going through, you know, challenging times. If you think about, beverage as a company and in an industry in 2000, people were getting very conscious with um, diet and obesity and, like, basically serving food, like, beverages and other things, carbonated beverages particularly. And they were going through a lot of innovation in their supply chain. And so we had to rethink like how logistics was organized and supply chain was conducted. And that led to a lot of like planning innovation, that led to a lot of like supply chain logistics innovation, which actually enabled the brands to continue to prosper. And then, like, I was very fortunate to work for other big companies, particularly like, Walt Disney. I enjoyed the most. We actually came up with the whole concept of Magic Band, which was building trust and transparency and also safety for, children in theme parks, and also making it a friction-free experience. And probably that was the first foray of basically like converging technology to data science to like customer experience. Very interesting kind of a journey there. And then like, with the big boxes, right, like Walmart and Target, like, very very interesting challenges. Grocery, as you all know, is one of those stable businesses that people tend to consume all the time. But like the supply chain that Walmart had, despite like Walmart being such a big retailer, like, they actually have 189 distribution centers, about like 55,000, you know, tractor trailers out there hauling the product, and driving around billions and billions of miles, pretty much on a daily basis, with a store fleet of 5,400 stores. And most of the customers are within like 7 miles of a Walmart, 93% of them. So, and we could not scale that model, the grocery model, from a delivery standpoint. So we had to basically figure out like how to enable that. Like, even given a company like Walmart couldn't actually figure like the logistical way to kind of unlock profitably something like that. And then the same challenge with Target. And so we were able to kind of transform that. So that actually led me to think like, hey, like all these big companies have a lot of leverage, have a lot of scale, sometimes they struggle. What does it feel like to be in a mid-tier company, right, in the midst of a tsunami of commerce, where to Gary's point, like, people are pampered by gratification, instant gratification. And that led me squarely into American Eagle. And what I'm going to share with you all at this time, um, is the remarkable kind of aha moment for me as a supply chain professional. Because there is a world beyond big companies. There is a lot of small and mid-tier companies. And like, how should the supply chain be organized was the question which was on my mind always. And so that led to this kind of this supply chain 4.0, right? And I wanted to take some time to walk you through that. It's kind of an infographic. Like, I'll be very uh, you know meticulous about, like, kind of walking through and giving you the context. And then, because all of the things that we are hearing right now, be it AI, be it basically like autonomous, be it basically predictive science, real-time decisioning, digital supply chains, they're all means to the end, to something which is getting formed, which I call supply chain 4.0, right? And that probably like will take different forms and fashion, whether you're a big box or a big company and a small or a mid-sized company, and how do you organize yourself to what's coming next. And that is what I would love to share with you all today, to kind of give you guys like my lens on like where things are headed. And it's just an individual perspective, but I see this like happening in other industries, and I'm kind of taking that anomaly and applying it to basically supply chain, which has been largely unorganized, efficient but unorganized, and basically there's a lot of room for improvement. So with that said, basically let me walk you through this concept of um, the supply chain 4.0. So if you guys step back and like basically I'm gonna date you back a little bit, and I'm gonna walk you through um, the concept here. And like I'm not a PowerPoint guy. Like I love to think about like things in images, and like like kind of talk about things, because that's how my mind works. So basically, like apologize that if you're expecting a very formalized presentation from me, like you're getting a infographic with like a lot of things to kind of like think through. So if you go back, so what I feel is like for every economic shift, the supply chain kind of was born to service that economy, right? And that's been the largely the premise of how supply chains have kind of evolved. So if you go back basically like the days of Ford and others, like like all of the economy was primarily kind of do it yourself kind of a thing, right? So basically
Shaker, do you
yeah,
mind actually increasing the width of the graphic a little bit? You can
yeah,
actually increase the whole screen, so we can actually see your whole desktop.
yeah. Can you
There you
see
go.
that now?
I think it's actually smaller that way.
Yeah, I know. So that's
Yep.
why like I had
Yep.
okay, got it. I'm gonna, can you see it better now?
Yes.
Okay.
Yep. Thank you.
Okay. So all of the world, like in the early stages, the economy 1.0, what I call the economy 1.0, was kind of like a one size fits all model. Like, think about like basically either like GM of the world, like, they made their cars, they had their like, distribution, they had like their parts. So it is a vertically integrated supply chain or kind of do it yourself kind of a model. That's where we largely existed, like in the early 1950s, 60s, and 70s. And supply chain was not even a word then, right? Like basically people managed like material movement, that's it. And they produced, so there was some production science associated with it. And that's where the world like largely existed. And like, we had a lot of small mom and pop, like, people that were actually servicing. So there was not like a notion of optimization. There was not a notion of basically like efficiencies. There were like work standards and work principles, which kind of largely guided all of your processes in the supply chain. Then there was a major economic shift. And this is when basically the globalization of supply chain started happening, right? And this is when basically like countries started thinking about trade efficiencies, right? So it was like what's ended up being what ended up happening is like as macroeconomics started like kind of unveiling itself, like every country started finding its own niche of where they can actually accelerate and where they can actually provide services. And in some places, basically America became like more of an innovation and services kind of a setup, and like Asia became more of your manufacturing hub, so to say. So there was trade efficiencies, and basically people were exchanging those trade economies that were getting like translated into a new supply chain which was getting formed. And all of the supply chain principles that you heard all the way from 1980s all the way through like like into early 2010s, even like 2000, probably like 12 and 13, was all about how do I intelligently source product. Okay, so much so that we made the supply chain so much leaner that it was like not resilient, like, and COVID actually kind of unveiled all of those scars for a lot of people. And basically it was also very slow moving, because like in this world, products were produced in one place. It was all about asset and labor efficiencies. It was all about sourcing efficiencies. It was about cost, and basically it was about the trade efficiencies, right? And supply chains were there to solve that sourcing problem and the planning problem, right? Am I making sense to all of you? So that's where like all of the genesis of the supply chain for the early 2000s and like late 1990s actually started playing in. Like, and that's why you had a whole host of systems. Once you got the procurement problem fixed, then you started thinking about, okay, how do I manage my demand and my supply, right? What is the ratio between inventory and my sales? And how do I manage that ratio of inventory to sales in a very, very intelligent form and fashion? And that's where there was a rise of like all of these ERP systems and planning systems, so to say, like JDAs, the Infos, the Manigistics of the world, the SAPs, the Oracles, and like, we know all those names. They're all like non-fungible data models, which actually largely made you focus your operations to the data models they actually kind of service to you, right? So it was not basically a very flexible system, but it solved a generic problem. The generic problem was, how do I make sure that the products that I'm actually making are getting there, like with the expectation of the inventory coverage, right? And we are largely even operating today in that model. If you look at like a lot of these industries, be it construction and other places, like it's still like in that very realm of sourcing from a different place, managing the supply chain efficiencies, and we are lighting up the supply chain, right? We are basically bringing like visibility to the dark spots in the supply chain and enhancing the planning and efficiencies associated with the supply chain, right? But I see a different trend when I started working for like basically the big boxes. And that I think is basically what I call the economy 3.0, right? In the economy 3.0, what started happening is basically we started getting into more of a unit economic model, right? So the distinct difference between, from a commerce standpoint, I'm just like coming at it from commerce, and you can extrapolate it to other industries too. What started happening was, in retail particularly, you went to the stores, you bought the product, and basically you brought it home. So it was kind of basically a self-service model, right? If you want to buy things, you do your own shit kind of model. So, but as you kind of move into this unit economy model, with particularly with Amazon and others, it became basically a full service model, right? The full service model is, I have to service the customer anywhere they want and anyhow they want. And I have to have all of the logistics capabilities to be able to manage to the problem, right? And Amazon, you like it or not, has been a behemoth trying to build the supply chain infrastructure which services the commerce platform, so to say, and really has mastered this unit economy problem. Unit economy is like, I go and like basically order a pencil, and like they figure out a way to get it to you and get it to you in the very fastest way and the cheapest cost, and they're coming closer and closer to where you live. So the transportation cost continues to kind of like come down because of the economies of scale, right? At the same time, when basically Amazon was kind of like pampering like the customers with a new mindset, we also have seen like the rise of the Airbnbs, the Ubers of the world, where basically there was a lot of sharing economy going on, to Greg's point, right? Like Greg was actually dead on, like those are the new norms of for something to stay here. And sharing economy became a very big like concept, so to say. And like, and I was telling you the story of Walmart. Like, even with Walmart, basically we could not get like our own grocery trucks to deliver to the customers in a profitable way. It cost us about $38 to make a delivery on a $110 basket, which is a losing proposition primarily. So we had to basically partner with someone like a Uber and our own associates, and basically like customers who are walking into the front door to make them a delivery agent. So it largely became a crowdsourced model, even for a company as big as Walmart is, right? So that was the rise of a different economic structure, where people demanded flexibility, consumers demanded flexibility, associates demanded flexibility, and basically like the existing paradigms of self-service model was completely disrupted. right? It was all like full service model, on demand, as I need that, right? So if you're, if you're like Amazon and if you're like Walmart, you may be like, you may be having the last laugh, because in a digital economy, the winner takes it all pretty much. That's what we've seen, like time and again. Uber, takes it all. Netflix takes it all, right? So Google takes it all. So we've seen that happen over and over. And so for all the other companies, like which are in this, which are trying to figure out like how to actually compete in the future, you should actually take what happened in the economy 3.0 and the supply chains which were created around that, which was around flexibility, around like inventory distribution and distributed logistics models, and basically figuring out how the transportation and logistics environment needs to like cater to the demand of one, right? And apply that to the enterprise scale. And that's basically where that's where the world is headed right now. That's what I call basically the economy 4.0. So all of this was going on from a business to consumer standpoint. What's going to happen next is whatever happened to the business to consumer interactions, which was highly digitized, highly flexible, asset sharing model, and trying to figure out how to best meet the consumer needs, now gets basically kind of thrown onto the business to business transactions, right? So this is where supply chain kind of needs to kind of like stay ahead of the game. Otherwise, you're going to be caught napping on this one. So, what do you expect in like in basically a economy 4.0? Well, you know, so this is where like I have a set of principles which actually guide that. Like, I don't define supply chain 4.0 as one thing or two things, so to say. It's basically a collection of principles, and once you have mastered those principles, you know that you're in a supply chain 4.0 kind of realm, pretty much. And I'm talking about my own experience, guys. Basically, like in Walmart, we used to move around like 500,000 containers, ocean containers. In a company like American Eagle or any other mid retailer, you're moving about like 5,000 containers. You don't have simply any leverage, right? So that's largely the big section of the world, and that section of the world should exist to maintain the genetic diversity of what consumers can actually buy and choose from. And that's where all of this principles become very, very important. And how do you tie them together? Like, AI is one of those, digitization is one of those, but like, there are some fundamental principles of how you want to think about a supply chain 4.0. And that's what I want you to walk away with today. Okay, so here are the principles for the supply chain 4.0. It has to be on demand, right? That is like one of the core principles of any supply chain. So today we build a supply chain and an infrastructure which is it's not flexible, it's not like variable, right? It primarily is like a very monolithical system. Like, suppose COVID happens and suppose you have to shut down one of your production centers, you're pretty much done, right? Like, if you have like a handful of production centers which are running your facilities, keeping those operations safe has become like a very challenging aspect. So how do you pop up an operation, be it COVID or not, for the surge capabilities that you need? And how do you maintain the variable cost structure in the supply chain? You have to think about all supply chains as being variable and being like less fixed in the future. And the only way you can achieve a very variable supply chain is by having things be on demand. So what do you need for that? Well, you need to have an enterprise software or like some kind of an operating system, which is pretty much a plug and play. Everyone in the virtual network, be it Rider, be it like, Geodis, or be it like anyone who can provide warehousing services, they're all pre-plumbed, good to go. And when you need them, you turn them on. When you don't need them, you turn them off. Okay, so it has to be, so assets have to be largely just like you order Uber, and like you basically like you get an Uber when you want it, and you basically like when you don't want it, you don't need to actually like summon for one. So the network as a whole not only needs to be morphable, but it needs to have an operating system which has like all of these layers plugged in, which basically helps you enable that. And you may be thinking like, is this guy just talking philosophy, or like, is this something which is going on like this? And I'm sure there is, and we are actually building this. Like we have our AEO company, the owner of the AEO company also owns many other brands, and we are in essence actually building this kind of a network to be able to make it all fungible, and that's what you've been reading in the news so far about our distributed logistics model. The second one is basically it's highly customer centric. You only win if basically customers are satisfied with you, right? So in this world where loyalty means like nothing, in this world basically like convenience means everything, flexibility means everything, and people are like generally browsing not for a specific product, for a company. They're actually like, they're just looking for, I want a widget. Like who cares basically if it comes from a Walmart or an Amazon or basically from a Target or anywhere else. They're like looking for widgets. And I think that the dilution of the brand basically makes it very difficult to kind of like be like less personal to customers. So basically like everything about the future of the supply chain, or the 4.0 supply chain, is built around the premise that you have to be catering to the demand of one. And you don't do it like, by throwing money at it. You just like do like that by creating frenemy networks. Take all the enemies of a common enemy and then make them your friends. And by doing that, how do you actually unleash like, very consumer centric kind of like a thinking on that? It has to be scalable for sure. It cannot be like, it has to be built on the premise of third parties and gig economy. I don't think there are going to be supply chains which are going to be fully owned by one service provider. It has to be like, Ryder has a play in this, Google has a play in this. It has like everyone who's either providing technology services and like service and labor, they all have a play into the mix. And basically that's how you're going to get to a very holistic way of managing capacity, because everyone is capacity constrained in their own limitation. But when you basically expand your thinking, like just like what Uber did, like, hey, like 96% of the car is actually sitting on waiting and not even like running around, so why do we need more cars? So I think like when you kind of open your mind to basically the availability of capacity as a whole, as a system, then you begin to unlock a lot of interesting things. And that was basically one of the things that we did, like, the Walmart and the Uber deal, and the Walmart and the crowdsource deals that we did. It has to be built on like what I call asset smart principles. Asset smart is primarily like, how do you like build transparency? This is what like, Greg was talking about. How do you basically manage transparency of service delivery and manage risk of bad actors? Whenever you're introducing a gig economy artist, or whenever you're basically going into a very variable supply chain, the reliability of the services are the most important thing that actually suffers, right? And when you're building a platform to manage this, that's the most important thing everyone forgets, right? When Uber was built, they never like thought that basically there's going to be a bad actor, very bad, that they didn't figure it out, but like there are bad actors, right? So one of the core premise of how you build a platform is basically think about like, information validation, and also basically like making sure that there is like trust and transparency built into the network. And that's a very core principles of service delivery and transparency that you're going to have. It has to be open and shared. It has to be multi-partner, and it has to be digitized for sure. Like, it is like, primarily associated with, many participants, and basically there's a digital twin to everything physical out there. And finally, like, you primarily think about like, safety and reliance in the supply chain. So this was one of the things. COVID actually was a rude awakening for a lot of people in many different ways, and for us too, right? Like, basically we ours is a $7 billion retail outfit, and we had like, 3 distribution centers, and a couple of them were actually at the risk of closing. So the business was on the brink of actually like, getting through like, very tough times. So and then you realize basically the safety and the redundancy of the supply chain, and how we need to actually start thinking about it. So that in a nutshell is basically all of the supply chain principles. But I don't want you to think that like the supply chain principles are like a vacuum, right? Like there are some examples of all of these things which were built out there.
Shaker,
Yes.
it's a very interesting and a profound topic, but because of the time limitations, I think we're going to actually have to cut you short, and then maybe actually answer some of these, talk about some of these actually as part of the panel discussion.
For sure.
Okay.
Yeah.
All right. Well, thank you very much. So what we're going to go do now is actually move into a panel discussion. And we would like everyone that actually has spoken as the speaker to all join the panel. And the panels are again, Todd, Mark, Ravi, Martin, Gary, and Shaker. I don't think Will's actually here anymore. Will said he actually had a soccer game that he actually had to go watch. Now that's a legitimate excuse for Will. So that's actually a pretty good one. Okay, so one of the things that we actually saw that actually promoted some thinking is people started to actually talk about the concept of smart supply chain, right? And also what we actually said is they actually are the need for an operating system. So self-organizing and self-optimizing production system is what we actually talked about. And based on all the technology that was actually promoted, or actually that was discussed, it seemed like there was two areas of focus that we actually saw. Again, just based on the topic that we're actually just talking, we put this together. There was some technologies that was working on the left side of the screen, which was the schedule. And what was someone actually that was actually thinking actually on the right side of the system. And as Mark correctly posed, the left side is the demand and right side is the actual transformation, which actually makes the production system work. And also some of the technology actually focused, as Todd actually mentioned, the automate, are you actually automating? Are you optimizing or innovating? And as what Martin pointed out, it was the levels of digitalization. But that actually had brought up a very, very interesting question while talking, was if we actually change our view from the customers of these solutions being a human to a machine, so that the machines can automatically respond, how does the solution design start to look different? It's a question that I'd like to actually pose to the panel. If we actually, so if the terminology visualization, the blind spots, all these are actually not from a human perspective, but from a bot perspective and machine consuming perspective, how does solutions start to differ? Gary or Martin?
I mean, one thing I found, not a direct answer, but maybe to kick it off, are humans ready for it? At least a few cases that shouldn't name companies or names at this point. But we have had a few situations where the machines could have done that, but the humans were not ready to accept what the machine would do. So I think that's a little bit of a back to culture and mindset. I think it'll take us some time in construction, maybe the kind of people we have to accept, that control, right? We accept it when, somebody, Uber, the example has been brought up many times. The driver cancels, well, the system finds another driver, and or you change your destination. All of these things are, there isn't somebody in the background with a AAA map trying to figure out stuff, right? Like we still do, kind of, in our industry. So, at least in my experience, that's the sort of bottleneck today. We can envision it, but then when we actually have it, do we really like it?
James, I was going to add, if the consumer or the customer is some kind of automated device, robot, whatever the case may be, it can and most often needs to consume a lot more information a lot faster. And so I would think if you looked at a GPS map in the old rental car days, you would say, okay, I got the big idea here and down the road I'm going, versus what an autonomous vehicle would require in the way of the feedback and feed forward, including the LiDAR, GPS, and all the other stuff that's going on. And so I think the limitations, so where the human brain is very profound in some computational capabilities, some of which Anil is talking about, on the other side, those limitations are not the same for autonomous type vehicles and robotics.
So Gary, from your perspective as the solution architect, when you actually look at these solutions and when you actually talk about these automated equipments, I mean, does the focus actually change from a consumer perspective of, you know, it's not a person that's going to actually read the schedule and try and actually what to the next step. It's actually a machine that's got to be automatically driven. How does that actually change how you design things?
Yeah, no, I think it applies to our business. I mean, the one thing that's never going to change for us is our customers won't go away. So we will have humans involved at some point in time. And to me, you start with your end customer and work backwards. If I look at kind of our strategy around what to focus on, it starts with the consumer first. As far as, you know, repetitive tasks, those are already being automated today. I mean, we're using RPA to take people off keyboards. We're using, you know, bots to respond to phone calls. So, you know, it changes the dynamic around what the person does or the role of an operator in our business. So if you take autonomous trucks, it's going to be a while until autonomous vehicles can deliver into cities. It's going to take a while. So, you know, the role of a driver for us, since we have like 9,000, 10,000 drivers, it will change over time. The role of a mechanic is changing right now. We're automating different activities in a shop. So, you know, alleviating time on tool is a key metric, but it's changing the role of an operator. I don't think you're going to be able to automate every single function in a supply chain. It's just not feasible. But what I do think it's doing right now, and it's going to accelerate, is the mundane, repetitive tasks. Those are the first things that are going to go. I mean, they're already going now. The more complicated tasks, it's going to take a little while. And that is a function of how complex the supply chain is, right? It's pretty hard to get to AI, you know, if you're trying to navigate across 300 different systems and your data is not normalized, right? And so I think the path around true automation will be constrained by your data management strategy. But, you know, the mundane tasks, the repetitive tasks, those are getting automated now. And even before you automate, you know, my view is you simplify and eliminate, because we're doing a lot of things that don't make sense today. So you start there, and then you digitize and automate and optimize. And so we're kind of on that journey now. I think it depends. I don't think you're going to get rid of all humans.
No.
No, I just think it changes the role of a supply chain or logistics professional. And it should, right? We should not be spending 50% of our time on phone calls or trying to collect data to do something with it, right? And those are the things that are going to change.
Right. Yeah, I think that the humans actually, as the demand for the supply chain services will continue to be there. I think it's the service providers themselves that actually are either automating the current practice or actually innovating to actually achieve competitive advantage, right?
Yep.
So the things like, were we actually ever ready for a smartphones? No, but now everybody has one, right? So it's that kind of analogy. Anything you actually want to add? Anyone else? Shaker or Ravi?
Yeah. So I think I think Gary and others said, right. First of all, I think acquiring the data and normalizing it, making sure it's truthful is becomes the foundation for these things, right? I think there are areas, isolated areas in the bigger processes that are getting automated. And the way we are automating that is typically, we are doing a baby steps in terms of building models, but, confounded by the humans, like, human assisted kind of automation, right? And then you deploy that slowly, it becomes like, a transition over to a full automation. So that's how the entire system will become automated by, piece by piece. That way we think is the low value, but high number of operations we are doing kind of thing, and then they'll go away. They get automated, and that's how and the entire system slowly get to that. And it will always be human assisted. Even today, even the autonomous vehicles, when we drive, we still kind of put some features in place and we watch it, we monitor it, get the confidence, and then we switch it over, right? I think it is in the direction, and then the amount of the data we get, amount of even the data, how correct it is, has to be, operated on in terms of, every piece of data comes in is not correct. You need to take multiple data points and you say, hey, is there truthful to is this correct? So I think we are pretty much installing these processes wise. We are installing validation processes through humans, through multi checkpoints, and I think we'll get there. We'll get there, but it's going to be a slow process.
I think like, so having been like an insider working in the companies, I feel like all decisions are driven by greed or by fear, right? So if the fear of something going bad is like bigger, then automatically I think, or like, if the pain is big, then I think like people will be more susceptible to change in those areas. Think about like basically like, where do we see the best use cases for real-time visibility and tracking and tracing? When like, there's a huge financial audit, or basically there is a large scale like, lawsuit or compliance issue, like then you're forced to basically understand what went on in that problem space. Like that's the dark spot. And basically that basically gets digitized, that gets like, like automated. I think if you pick those areas where your biggest pain is, and you have to just keep asking yourself, is the juice worth the squeeze? And where do I first like get into the system, right? I think that's the entry point of where you begin like, processing some of these things. And I think that will actually drive the adoption. The other one is like obviously greed. Like, if the financial benefit of doing something is like astronomically big, then you are motivated to do that, right? So in that case, basically like, it could be either a revenue recognition problem, or it is basically like profitability, and the profitability is so huge that like the change management is is much smaller in context. And then I think like you get like quick adoption on those things. And that's where I've seen like a lot of either robotic adoptions, or like think about customer service and customer care calls, right? Like, it's one of those pain points that you'd never want to deal with, and like, you want to just automate the heck out of it. So I think you see adoption there. And I agree with everyone that basically it's always going to be human in the loop systems. And until we build the confidence, I think like it's going to continue to be. And I think the degree of human in the loop changes by process too.
Yeah, so there are a few other questions, but due to the time limitations, we'll actually pose these questions to the panel, and then we'll actually get back to the questionnaires. Okay, so thank you, everybody, especially the panelists that actually have joined today to present your views and provide us insights. So after 25 minutes of break, what we're going to actually do is actually have two sessions in parallel going on. One is how do you actually lead companies implement and benefit from project production management. And the other track is industrialization of construction. What are the challenges and how to address them? One of the trends that we actually seen is a lot of people are talking about factory models, industrialization, and sometimes a lot of the things that we're actually trying to do in digitalization is a step to get to industrialization. So that's going to be a very, very interesting discussion as well. So please join us for that session, and thank you for attending this one.